Hello class, welcome to 3.9a scatter plots. Before we get started, let's take a look at some definitions. So a scatter plot is a graph of ordered pairs involving two sets of data. These plots are used to detect whether the two sets of data are related. We also have what is called the line of best fit. This is going to be the trend line that shows the relationship between two sets of data most accurately. Okay, so then we also, with these two things, we have a couple types of correlation. So when we're looking at how these two are related, in your scatter plot, we could see what's called the positive correlation. This is going to be as one value increases, the other value also increases. A negative correlation is going to be a negative slope where you can see one value increases but the other value decreases. And then lastly, there is a no relationship between the two sets of data if you just have points that are all over the place. We don't really see any type of line that could be drawn through there. Problem is you could draw it this way, this way, this way, any direction. Where the other two have a pretty distinct line that you can see going up or down. Example 1. Is there a relationship between the number of days you are absent and your grades in school? Let's use the table to the right to create a scatter plot and find out. All right, so first thing we want to kind of look at is doing a scatter plot. So we want to make sure we're starting off with some labels. We'll have our number of days absent on the x-axis and our grades on the y-axis. So when we go to look at these and we want to kind of take a look at our range of values, and it looks like we go anywhere from 2 to 11, and it looks like we're going to have enough spots to kind of go through and just count by ones. So if we fill that out, 9, 10, 11, 12, we're good. Now on the other hand, for all the way up to 94, this looks like we might have to count by tens. So we want to make sure we're picking an interval that's even. That's going to cover all the numbers we want to look at. So if we go up through 80, 90, 100, that's enough. We could put 110 up there just to kind of take a look in case someone got some bonus points. But really, the first step of creating a scatter plot is treat each one of these points as a basically each of these pairs as a point where the x is your 2 and the y would be your value. So we're going to look at 2, 94. We're going to get something up there. We're going to look at 3, 84. And we're going to go up the 3 value and find something a little bit less than half. All right, so finish those up. So the first question asks, what type of relationship do you think attendance and grade has? Well, we kind of took a minute to graph them, but even as we look at that go down, we're going to look at this being something that's probably negative. So when we draw that scatter plot for part B and we are labeling axes, we kind of did jumped ahead that step. But the next thing we want to look is draw your line of best fit. So this is where we're going to get our ruler out and try our best to go right through those points. So if you are drawing your own line of best fit, this is going to be something that goes through the data as best as we can. So when you look down through that, you're going to try to make sure your straight line goes straight down through as many of those points as possible. And in this one, it actually looks like our points are pretty well lined up with a line. But we want to make sure it's through the middle best we can. And as we even look at this, yeah, that kind of just verifies that if we have a negative slope, which it looks like this is, they will have a negative relationship. Because it's basically telling us the more days you miss, your grades are going down, right? That should almost be common sense for you. If you ever miss a day of school, you're missing material, you're missing information, and we're looking at all of that. And we don't really want to have that happen. So the next question is finding the slope of the line. Well, now that we have that line in there, this is what we've been doing for a while. And right now, we're just going to estimate the best we can to kind of see where these points are going from. And so we're going to kind of want to look at like 2 points that are going to be the best we can that look like we're going through some values. So the one thing I'm looking at here, especially when we look at our line, we don't necessarily want to look at the points anymore, but we want to try to maybe look at this value here that goes through a point, and we might want to try to take that all the way down to here, which looks like it goes through another point. So when you look at these values, we have to be careful, because that looks like it goes from 80 to 50, which is really down 30. We can't just say down 3 anymore because we're counting by tens. But when we do look from 4 to 11, that looks like it's going for a run of 7. So if we're going to look at our slope, that would best be represented by a negative 30 over 7. And then, if we are looking for the y-intercept, well, where do we find that y-intercept? Trace that line, which it looks like here, or it looks like that y-intercept on this line is pretty close to a 99. Okay, so looking at those two things, this is enough information for us to write an equation. So if we have our slope of negative 30 over 7x plus 99, that is now a graph that we can, or equation that we could use to predict as much as possible. And we'll take a look at how to predict in some other ways on the next slide. So we will look at using the line of best fit to make predictions. On the last slide, we looked at how to create it, draw them, and even write an equation. But if you have problems that already have the graph, what we can use is that line to estimate the y value or x value. If we know, or option 2 is if we know the equation for the line, we could use that to calculate your y value or x value. So let's look at it through the first example. So based on the line of best fit, how many hours would a student have to score to get a score of 85? So over here, we're looking at hours of study versus test scores. Well, that makes sense, right? This is another just positive correlation, because the more hours we study, the more or better grade we should get. So we're just going to look through here and say, well, where is a score of 85, which would be about here on your graph. So what we would need to do is kind of trace this over till we hit the line, and then we want to kind of trace down to figure out that's going to be somewhere probably around 85. That would probably be about like a 22 to 23 hours. If a student studies for 30 hours, so let's look at that in red. So now we're going to look at 30 hours. What will their test score be? Well, this one now is talking about 30 hours, so we're going to start down here at 30 hours. Well, let's just kind of follow that line up. It's going to get us about right here. And if we trace that over to our test score, looks like that's going to be somewhere around the 98 to 99% percent. So take our best guess there. How many hours would a student have to study to get a score of 70? Okay, so if we're going to look at a score of 70, again, where is that going to trace to our graph? Somewhere about there. Trace that down. I'd say that's probably about 12 hours. Just a slightly offset. And then our last one is asking for 15 hours. So again, just to look there, make sure we're finding the first one. That's going to trace us up to about here. And then that's going to trace us over to, what is that, about 74, 75, something along those lines as far as our test score. If we want to use an equation to figure these out, that's just going to take a little extra step to start off. Looking back to what we did on the last one, that would mean we would basically need to find 2 points. So we're going to look here in black. Find a point that looks nice on the line and on 2 axis. So I'm looking at those two. Those are the first 2 that jump out. Now that looks like from 60 to 90, that looks like that's going to be a rise of about 30. and then we're going from 5 to 25, so that would be about 20. So if we're going to look at our slope, that means 30 over 20 would really be 3/2. And what else do we need to write an equation? We would need to kind of predict our best prediction of where that y-intercept is. And right there, that looks like maybe we'll just go with 51. So that means if we look at y equals 3/2 x plus 51, we have an equation we can work with. So let's just see how close our guesses off the graph are. So if we're going to look at this first example, and I'm just going to have to work right underneath here for the time being. But what we're going to look at is if we have a score of 85. Well, the score was our y-axis. So that means if we say, well, what is 85 and how are we going to solve here? So plus 51, that would allow us to subtract 51 from both sides. That's going to leave us with a 34 equals 3/2 x. So at this step, we will multiply by the reciprocal instead of dividing. And really, that's going to come down to what is 2/3 times 34. So plug that in your calculator. And that looks like we're going to have about 22.6 repeating. So that would end up being very close to our, well, right in between our 22 to 23 hours, almost right in the middle. Now, if we kind of look back at the second example here, example B, I'm going to go up here in the right corner just so I have a little bit more room. So if we are looking at 30 hours for this one, well, that means we are going to be looking at hours on our x-axis. So if we have 3/2 times 30 plus our 51, plugging into that equation. So that's going to really be, well, what's 3/2 of 30? So that looks like 45 plus 51. Now, if we use this estimation, we're going to get ourselves about a 96, which ends up being a little bit less than what our graph prediction was. But, you know, it all comes down to just where we draw our lines and pictures. So we'll talk about a more accurate way using the calculators like we did in Zoom. So let's take a look at some examples or some practice moving forward. So pause here and practice what we just talked about before you move on to check your work. In example 1, you can see here, it doesn't matter whether we use our graph or our equations. In this case, both of them line up a little bit nicer to be our 8 and 6. And again, just make sure you're finding your slope and y-intercept. So when we look at this one here, not lining up real well, but we can see A is probably like 41 to 42. If we look at B, that'd be about 9, somewhere between 9 and 10. If we look at our slope, make sure you're picking good points. So that looks like that would be about rise of 10, run of 2, so 5. And we might even have to extend our graph a little bit and get to the y-intercept of -5. So again, this isn't an exact science right now, but it does get us or break us down and use some reasoning to try to answer these questions. Okay, example 3. Got a lot of different lines drawn in there, trying to match them up with the colors, especially once we get to the blue, green, yellow, to kind of estimate those. This one also wanted us to try to use the equation one time to figure out 30. So if we plugged in 30 and we looked at it on the graph versus 30 and our equation, well, both of those kind of end up around that 76 to 77,000. But based off of the numbers we estimated, or at least I estimated, hopefully yours is pretty close to that 36,000 and slope. And the only problem is, you know, some of these might not always match up, but they should be pretty close depending on how you interpret the graph. And lastly, what relationship does this have? Well, you can see very clearly that this is going down, so that should be a -1. And we want to make sure we pick that third example because that is the one that best goes through all of the points. This first one looks like it's a little underneath everything, so we wouldn't really want to go with that underneath. And this one looks like a little tilted here. It looks like it starts below, then it gets above them. But this one more directly reflects right through the middle as best as we can. Okay, so that kind of takes care of just looking at graphs, reading graphs. And we'll talk a lot more about our calculators and the LinReg and a few ways to kind of get more accurate. So everybody should be getting the same answer. So other than that, hope you had a good lesson. Make sure we ask any questions otherwise if you came up with any. Have a nice day.